All right. So, some of you, if you're choosing to write this down, you probably should have the top 3 done by now. Okay. These are your choices. There's one of each up here. We've got okay, oops, combustion's not up there twice. There we go. Yes, what? Okay, so this top reaction, if this was your evaluation, what would you place for this top reaction? Okay, you're right, but how do we know this is a decomposition reaction? Because this is splitting apart into separate pieces. So this is a decomposition. Then the last thing to do is balance that. Okay. How would we go about balancing that? Give me some elements that you see. Potassium's left. Potassium's right. Chloride's left. Chloride's right. Oxygen's left. Just say it, please. Don't add extra noise in the background. Okay? Okay, so where are we going to start? These are odd. How do we get this up to an even number? Okay? That gets distributed through the entire compound. Okay? How many potassiums? Okay? Okay? What do we do to the other side now? Right, I know. Balance it. That? Okay. Your number on your oh. Okay. Next, reaction down. Just to help us out, you two gentlemen, turn around, please.
I'm doing cooperative learning.
I know, but we're working on this. You can do that later. Turn around, please. Okay. Now, when it comes to this, how do you know if subscripts are going to the other side for sure?
If they're oxidated.
No.
I don't know.
If it's part of the formula of the polyatomic ion. That is correct. That's why this 3 is over here. Okay? Why is that 2 there? There wasn't a 2 over here.
Because you had to get it equal.
He had to get the charges to add up to 0. Okay? Why did we not just leave this as 1? Because it's diatomic. Okay? So, what type of reaction would you think this is? Okay? Okay? So you got 2 nitrates over there and only 1 over here. So what do? Okay? And that's it. Now it's balanced. Okay? What type of reaction does this resemble? Okay, you are right when you say it's a combustion reaction. Why is it a combustion reaction? Because you've got carbon dioxide and water, but more importantly, what is this? It's a hydrocarbon. It just says hydrogen and carbon only. That's why it's a hydrocarbon. Now, what else do you need to recognize to make it much easier for yourself? Why is being even significant? Okay, and I understand these numbers are going to get quite big. That's true. So if we're going to do that, how many carbons is that now? 20. And how many carbons are over here? So how do we get that up to a 10? Okay. All right. So how many hydrogens do we have? Okay. And how many hydrogens are over here? Okay. Okay. So what does that give us then?
31.
Okay. So how do we get 62 over here? 31. All right. Okay. What type of reaction does this one look like? Synthesis. Okay. Do we need to change anything? No, it's already balanced. Okay. Now, why? Do you want to stay in here?
No, he doesn't. Not really. I don't even.
Okay, so how do we continue to do this? What happens in a double replacement reaction? Okay, the charges do not change. We said start with your negative ions. So what does carbonate have? Negative. Okay, what does ammonium have? Plus what? Okay, what does the chloride ion have? What does the potassium ion have? Okay, so what does ammonium bond to from this compound but on that side? Okay? Okay? Then what does potassium bond to but from this compound but on that side? Okay? Now, of all of these subscripts, why did that 4 end up over there? It's part of the formula. Okay? So you correctly said potassium. Does that 3 go over there?
No.
Yes, it does. Okay? Plus 1, minus 2. That does not add up to 0. 2 potassiums. Okay? All right. So last thing to do is to balance this. You've got 2 ammoniums here and only 1 over here. So what do? That gets distributed through the entire compound. Okay? What does that do to your chlorides? 2 times 1. So how do you get 2 chlorides over here? Now it's balanced. All right. So for those of you who are gone, okay, we will put on the Science Channel. Do you want to discuss that activity today? And I understand. We're going to be doing that on Thursday. We're going to say, well, we're in track. We're not going to be here. Well, then you're going to do that on Friday. That makes sense. Okay? So, do you want to discuss that activity today that you're going to be doing over in the lab? Or do you want to be just put on the Science Channel? Asking for input. All right. We'll catch up to you next time.